Welcome back. I'm sorry the first slides we did in class, so I haven't recorded them. But question 6.1.3 and 4 you had to do for homework. So we had to get the empirical formula for glycerine, and that is the empirical formula for glycerine. And we see that the molecular formula for glycerine is exactly the same thing. And now they say write down the value of X in the equation above. So to get the value of X, we need to actually balance the equation. So I'm going to do it in a primitive way, where we are going to write down as it is, write down each element and how many atoms are present on the left-hand side of the arrow and then on the right-hand side of the arrow. So at this point in time, we've got 14 potassiums on the left-hand side. Manganese atoms, we've got 14. Oxygen atoms is a bit tricky, but let's write them down. We've got 14 times 4 plus another 3. So that is 59 atoms of oxygen. Carbon atoms, we've got 3 at this point in time. Hydrogen atoms, we've got 8 at this point in time. Then we go to the right-hand side of the arrows, the product side. For potassiums, we've got 2 times 7, that is 14, so they are balanced. For manganese, we've got 14. Those atoms are balanced. For oxygen, we've got 21 from here, 21. And here we've got another 21. And here we've got 2. And there we've got 16. So it's 42, 44, 50, it's 60. So oxygens are not balanced at this point in time. Carbons, on the product side, we've got 7 plus 1, that's 8. And hydrogens, we've got 32. Now we need to start the process of balancing. And if I look at this, to multiply the number of hydrogens here by 4 would give me 32 to balance that. So to multiply here by the glycerine by 4 would change the hydrogens to 32. Now I need to re-look at the situation. 4 times 3 for carbon is 12. And 4 times 3 for oxygen is 12 plus the 14 times 4, that makes it 68 atoms of oxygen. We remain with 14 manganese and 14 potassiums. Now we need to try, so we've got the following. That's balanced. That's balanced, that's balanced. Now we need to balance the oxygens and the carbons. We need to use another color. To balance the oxygens and the carbons, I think it would be easier to balance the carbons. So I've got 7. I've got 7 carbons here, and if I add 5 carbons, we'll get 12 carbons. So if I multiply the carbon dioxide by 5 and I add 7, we get 12. So the carbons are balanced. Now we need to check the oxygens. We've got 21 oxygens plus 21 oxygens, and here we now have 10 oxygens, so that makes it 52 plus the 16 oxygens there makes it 68. So the equation is balanced, and to answer the question at the end, the value of X is 5. Right. Right, the next question is calculate the mass of Mn2O3 that can be prepared if 18 grams of KMnO4 reacts with an excess glycerine. Now we need the balanced equation for this, and from the balanced equation we see that 14 potassium permanganate gives us 7 of these Mn2O3 compounds. So the mole ratio is 14 to 7, which is the same as 2 to 1 if we simplify. Okay, now it's a normal mass calculation, so we've got 18 grams of potassium permanganate, and we need to get the mass of this manganese oxide compound. So in order to get that, I need to calculate the moles of each of the potassium permanganate. So moles is mass over molar mass, which is the 18 over. Now the molar mass for potassium permanganate, potassium is 39, manganese is 55, and we've got 4 oxygens. 4 times 16, that gives us 158, and 18 divided by 158 is 0.114 if I want to round the 3, because after the 3 there's a 9 mole. So the mole ratio is 2 to 1. So to get the moles of Mn2O3 that formed, I need to divide this number by 2. So the moles here is divide 0.114 by 2, and we get 0.057 moles. To get the mass, it's moles times molar mass, so it's this 0.057, and the molar mass for Mn2O3 is 2 times 55 plus 3 times 16, which is 158. No, man. Really? Can't believe this. So it's 2 times 55 plus 3 times 16. It is 158. Okay, times by 0.057, and we get 9,006 grams, which should actually be 9 grams. Or you could say 9,01 if you round it off properly. Right, it should be half of 80 because these two compounds have the same molecular or molar mass. Right, I hope you found this useful. I'll post it to you ASAP. Thank you for watching.